All right, we're going to pick up where we left off in part 1. So here's 18 through the end. Now, there are problems I'm going to cut out, so you want to look carefully. Some of these are more than we need to do. This is a review that kind of has above and beyond, which is good. If you want a challenge, it's here. So determine whether CS and KP are parallel, perpendicular, or neither. So we're back to doing both of these, determining whether or not they're parallel, perpendicular, or neither. So here kind of how that takes place. So this will go a little quickly. Again, you can pause as you need. We need the slope of the first one, shown here, and the slope of the second one, that's KP. Kind of looks like a funny symbol in there. But do the y's on the top and the x's on the bottom, subtract in the same order. You get 2/3 for one, 4/6 for the other. And you might say, those are not equal. They're not opposite reciprocal. You might say neither, but remember, you got to simplify those fractions. Those are both 2/3. We're talking parallel lines. Then 19 says write the slope-intercept form. That means take that -9. That means just to take and drop those in. It's about as literal as it gets. Slope in one spot, y-intercept in the other, move on. Then the next one, 20, is more of a challenge than I'll ask of you on a test or anything, but it has the right concept to it. So I should tell you right now, an x-intercept is on the x-axis. Its coordinates are whatever the x value is, 3, 0. So that'd be the x-intercept of 3. And a y-intercept is always 0, whatever the y-intercept is. So that's 0, -1, since our y-intercept is -1. Those are 2 points. Now, I do need you to be able to find the equation of a line through 2 points. There's 2 parts you need. The slope, which you get from, you know how to get the slope between 2 points, 1/3. Then you want to use that y minus y1. Let me put that down at the bottom so you have that. Remember this is called point-slope form. And if you have the slope and a point, you put the point in for x1 and y1, leave y and x, just y and x, slope in for m, you have your equation. So here it is. I'm going to go highlight those. 3 goes in where -3 is, and 0 goes in where 0 is for the y1 coordinate, and then the 1/3 goes in for m. What you do is simplify from there. Distribute the 1/3, and if there's a number next to the y, you subtract or add it. So in this case, we get 1/3 x minus 1, and the 1 comes from, the -1 is 1/3 times -3, which is -1, highlighted down there at the bottom. So next page, here's problem number 21, similar kind of context. So what you get is a point and a slope, and so you want to use point-slope form. You just need to be able to fill in the blanks for this formula for point-slope form. The values of m, x, and y go in their appropriate places, so I've indicated those here. And then you look into the problems options and you say, hey, which one has the right stuff? C. So we move on, go to the next page. Here's how that plays out. You have to substitute the x and y into that y minus y1 equals m times x minus x1. Again, x1 and y1 are where you put the 2 points. You got cut off on this page, but actually there's clues enough to make this work. If you're going to put y1 into the formula, it'd be y minus y1. Only one of these has a minus 12.8, which is appropriate to this function. And so you want to choose B in this option here. Usually I'll give you enough room to read them, and that's actually what you're going to see now in number 23. So let's keep cruising. Again, the equation of the line containing these 2 points gets slope first. And if you look at this one in number 23, you get -2 as a slope. The only one with a slope of -2 is D, -2x plus 7. That means the slope is -2, so we could stop there. Just so you know, we would, if you kept going, you'd put one of the points, and I chose 6, -5. You'd have the y1 here and the x in the other side. And if you distribute the -2 and then you add or subtract 5 with both sides, we would get the equation on the right anyway, but that's just kind of a shortcut. Well, let me show you all the steps. In number 24, here are all the steps, no shortcuts taken. Here's how, if you have 2 points, you want the equation of a line. First you get the slope, which is 3, and then what you do is you write the equation out with everything filled in and want to distribute. So I just put this all on the page so I can kind of walk you through it, but you distribute the 3 first inside there. That's what you have down below, and then you subtract or add the 15 to both sides. When you add 15 to both sides, -21 plus 15 makes -6, and that makes 3x minus 6. Y equals 3x minus 6 because these 15's canceled, and that's C as our answer choice. So now if you want to see the 3 letters, there they are for what the correct answers for 22 to 24 are. Okay, so now it's deciding whether lines are parallel. So in number 25, what you want to identify with angles 1 and 2 is you want to find the transversal they both touch. So the only thing we can talk about are angles in parallel lines that touch the same transversal. So 1 and 2 touch that orange transversal. Those are alternate interior. That means those yellow lines are parallel to each other. So what is that? CA and FD. CA, whoopsie, wrong touch here. So CA is parallel to FD. Here's the idea. 2 lines. Okay. And then we go into the next one, which is DAB and EBC. So I highlighted them above. Those are corresponding angles. And what it makes is AD is parallel to, say, BE on the bottom there, because those corresponding angles are equal. They touch the same transversal, and if you can't see it, it's there. Okay, so that's the transversal they both touch. What that indicates, by those being congruent, those are corresponding angles, AD and BE are parallel. Next, we got to look at 28 and on. Now, there's a point missing. You guys have it on yours, on number 29.03 or 03. This is construct a line perpendicular to M. So then find the distance from P to M to P. Well, I'm not going to ask you to find the distance. I am going to ask you to construct a perpendicular. The distance piece, we're going to have to look at another time. Maybe a project is where I'm headed. So take a peek at this. In fact, what I'm thinking on this problem is that I really just want to use it as a teaching tool. So don't worry about 28 on to, what was that, 31 on that page. You want to just make sure you understand parallel and perpendicular. What I want to indicate is that perpendicular lines, we know when they're up and down and left and right. One has an undefined slope in 28 here, and the other has a horizontal slope of 0. 0 fun and is that horizontal for skiing, and undefined here as you fall off the cliff. When they're slanted, they're not up and down like that. We have to remember, all right, one slope on that one line is down 3 over 2. We call that -3 halves. It's downhill. It's nice and negative, as you know. Then the other slope, notice the perpendicular slope in this one is less steep. And what we need to know is that by less steep, it's actually a smaller number. So it's not, so -3 halves is a pretty steep slope for the downhill one. Well, the uphill perpendicular slope is not as steep when it's perpendicular. It's a smaller fraction, 2/3, and it's positive. We have to remember that big and that goes with perpendicular lines. Opposite and reciprocal. Keep that in mind. Excellent. Well, that kind of concludes that piece. To the end, there's 33 to 35, and those are just identifying the pairs and what kind of angles they are. So just carefully go through these and say 5, 13. Yeah, those are corresponding angles, and you just need the name of those. Hey, 7 and 12. Let's see, 7 and 12. Alternate interior angles. Yep, they go on either side. Remember, they have to share a transversal to be of importance to us. So be careful about that. And then we go to 9 and 16. I guess I better pick a different color real fast. 9. I can't even see it in my drawing here. Where is 9 and 16? I see 16. Oh, there's 9. It's underneath my writing. Those are alternate exterior angles. And again, they have to touch the same transversal. These are the 3 pairs that are equal in parallel lines. Are they congruent in parallel lines? Remember, same side interior are the ones that are supplementary when the lines are parallel. That should do it. Please email with questions as they come up. See you soon.